Hey guys, this is Mr. C, and today we're going to talk about piecewise functions. So first thing we're going to do is we're going to evaluate some piecewise functions. And so what is a piecewise function? A piecewise function is a function that's been split up into pieces, and that's why they call it piecewise. And what happens is you get, like this graph right here, you get this line that comes down. Even though the arrow's here, it is going down from left to right. It's going down here. And then what happens is it stops here, it includes this value, but then it jumps down here to this one and then goes up. And this happens a lot in electrical engineering and in physics. And so you're gonna see these problems in science sometimes, and anytime you get some type of a big jump in values in your domain. And so what we wanna do is we wanna be able to figure out what the function value is for each of these domain values. And so this graph goes from -6 all the way up to +6. And so that's our domain right here. And we see for the domain for this one, that it starts at an arrow, you go over, the only problem is right here, but that closed circle is covered by that open circle here. Both of them are covered. And so as long as that's covered, that one's closed, that one's open, that's not defined, but that one is. So that value of -2 is covered there, we're good. And then it keeps going on and on and on until you get to the arrow. So our domain for this is all real numbers. Sometimes it's all real numbers, and sometimes it actually does jump and there's a gap between these two pieces. So kind of expect ones like that every once in a while. All right, so what is f of 2? Okay, so what this is this means in our domain for the value of 2, what is f of 2? What's the y value? So let's go to 2 here. And at 2, we see that the graph is right there. That's the point. So when x is 2, my y value is -1. That means that f of 2 is equal to -1. That's what f of 2 is. And that's all you have to do. All right, let's look at several of these examples. So in this one, same graph, f of -2. So we go back to -2 for our domain, and we go down. We never want to go to the open circle. We always want to go to the closed circle. So -2 down here to the closed circle. Whenever there's a choice, you always pick the closed circle. And over here, it's -1 for that one. So we get -1 for that one. Okay, for this one, 3 pieces for this one. And now we have to figure out what f of 2 is. So we go over to 2 for our domain, because that's what this means. And then we go down, well, there's an open circle. We don't want that one. We don't want -2. We want to go all the way down to the closed circle. And if we go over, we see that that value, f of 2, is equal to -5 for that one. Okay, on this one, -4. So we'll go back to -4, and then we go to where we see the graph of f of x. It's not down here at all. It's right up here. And so that right there is the point. And so if I go up, then go over, 4 is the y value there. And that's what we want. F of -4 is 4. All right, let's take a look at this one. -2. All right, so again, at -2, we go up. Okay, there's your closed circle. Don't go here. Closed circle is 2. That's the y value. And f of -2 is +2. Okay, on this one, we want f of 4. So we're going to go over to 4 in our domain. Go to the graph. It's right here. So we're talking about this point right there. So the y coordinate of that point is -2. So that's equal to -2. All right. -5 for this one. Here we have a weird looking piece. This is a quadratic, and then it turns out there is a gap between these. And so the domain is not all real numbers this time. There's a gap between 0 and 1. So we can't talk about anything in here. Well, luckily -5 is not in here. So here's -5 for our domain. Let's go up until we hit the graph. Looks like it's right here. Let's go over till we find the y value. And so it says 5. And so f of -5 is 5. And that's all you have to do for these. F of 0. So here's f of 0, and we have a open circle. We have no closed circle. right there. There's nothing other than the open circle. So the graph comes all the way up to here and then stops right before it gets to 0. So since there is no closed circle here, we're going to write undefined for that one. And that's what that looks like. There is no value of f of 0. You can't even report it. All right, this one, f of -2. So let's go back to -2 in our domain. We'll go down here to the graph. It looks like it's that point right there on the graph. We go over, and -4 is it. So -4 is f of -2. Okay, for this one, f of 3. Let's go over to 3. Okay, we've got to go up to get to the graph right there. What's that y value? It looks like 1. So equals 1. And now we have, again, a piecewise. We have a linear piece and then a square root function piece. So here's -1, right? -1. We got to go down till we hit the graph right there. And it looks like that y value, it's a little obscured, but that y value is -1 right there. So it's a coincidence that these two numbers are the same. So it's -1 for the y value right there. And so for this one, f of 2, so we go over to 2. Here it is on the graph, and it looks like that's right where it intersects the x-axis, and that y value right there is 0. And so f of 2 is 0. Okay, f of -2. Okay, go back to -2. Again, we have a choice between open circle and closed. We always take the closed right there. And that corresponding y value is -2. Again, that's just a coincidence, but it is -2 for that one. All right, so now we have some piecewise functions by definition. So now we have to find f of -1 from this definition right here in function form. So here we have two pieces, and it looks like 1 in the domain is where the split occurs. So -1 is on which one? Is -1 less than 1 or greater than or equal to 1? Well, -1 is definitely less than 1. So we want this one right here. And so we're going to use this one right here, right? So we're going to cross through that one. We don't want to use it. -1 is less than 1. So we go over here. And this is where we're going to plug that -1 into. So what we need to do is figure out what f of -1 is. 3 times -1 minus 2 is equal to -3 minus 2. And so our value is going to be -5 for that one. Okay, so this one, we want f of -3. So here's our function, and it looks like the split occurs at -3, less than or equal to, and then greater than. So no graph again this time. So where's -3? Is -3 less than or equal to -3, or is it greater than -3? Well, -3 is equal to -3. So we want this one. So we're going to cross through this one. We don't even want to look at it. And we're going to plug that -3 in right here. Okay, so that -3 goes in here. 4 times -3 is going to be -12 for that one. All right. Next one, let's see if I can get these pages apart here. Okay, they're going to get a little complicated, but that's okay. F of 5, and again, the break occurs or the split at 5 for our domain. So is 5 less than 5, or is 5 greater than or equal to 5? Well, 5 is definitely greater than or equal to 5. It's equal to 5. So we don't want this one, so we're going to cross through that, and we're going to put that 5 in for x right here. We don't stick that 5 in here because nothing's going to happen. This just tells us which piece to use. This one's where we're going to plug it in. And so we want the square root of 5 plus 4, which happens to be the square root of 9, and that is going to be 3. So f of 5 is equal to 3. Never plug it into both of them. All right, in this one, we have 3 pieces. And so it's been split a couple times. X is less than or equal to -2, -2 less than x less than or equal to 1, and x greater than 1. So it looks like we have 2 splits. One split is at -2, and the other split is at 1. We want to find out what f of 0 is. So is 0 less than or equal to -2? And the answer is no, it's not less than -2. So we're going to cross through that one. Is 0 between -2 and 1? Definitely. So since 0 is between -2 and 1, we're going to cross through this one, and we're only going to use the middle one. So we're going to plug that 0 in right here, and now we want 4 times 0, which happens to be 0. So for this piecewise function, f of 0 is equal to 0. All right. Here we have one that's a little more complicated, f of -3. Looks like we have two splits again. One's occurring at -1 and the other one's occurring at 4. So is -3 less than -1? And the answer is yes, it is. So we're not going to look at either of these then this time. We're only going to look at the top one. So we're going to plug that -3 in right there. So we want -3 squared minus 1. And I use parentheses because I'm evaluating a negative number here, and I have to be careful because of that squaring part. So -3 squared is +9. Take away 1, and 9 take away 1 is 8. So that's our answer for this one. All right, so how can this get more complicated? It can get a little more complicated. Here we have a piecewise function graph, and we need to write the piecewise function for it. So this should be fun. So let's see what we got here. So what we have is we have two pieces going on. We've got this piece, and then we have this piece. All right, so if this line here, if this was a line and not just a ray, okay, what would be the equation of this? So let's take a look. It's got a slope of -1, right? Down 1 over 1. The y-intercept, if you keep going, would actually, the y-intercept would actually pass through right there at -2. So for the first piece, we're looking at -x from the slope and then -2 from the y-intercept. And that's for x all the way up to -1 right there, right? So for all x, and it is a closed circle, less than or equal to -1. This piece starts down here with an open circle and goes up. It has a slope of 2 and has a y-intercept of -1. So we have positive 2x from the slope minus 1 from the y-intercept for everything else in the domain. And the domain is all reals because that point's covered right there. So for all x, and that would be greater than, strictly greater than, -1. And that is our function, f of x. And that's what you would have to write. Those get a little bit more complicated, so you might want to play that one back a couple times so you can kind of get the process down. And we've got one more for you. Okay, this one, here's piece number 1. I'll label this one too. I didn't do that last time. Piece number 2. Okay, so we got piece number 1. We have a slope of, it looks like 1/2 and a y-intercept of 1. So we have 1/2 x and then plus 1. Okay, that will give us the entire line, but we don't want to keep going. We want to stop at 2. And so for everything from 2 on back and not including 2, so for all x strictly less than 2. So open circles get strict inequalities. Okay, so that's piece number 1. Piece number 2 has a slope of -2, down 2 over 1, down 2 over 1. And so let's take a look and see what that y-intercept would be. So if you keep going, back 1 up 2, it looks like it would keep going like this, right? And it would eventually hit 4 for the y-intercept. So we have -2x and then plus 4. And that is for which part of the domain? From 2 on forward. So x greater than or equal to 2. We'll put a big bracket there, curly bracket, and f of x equals, and that's our definition for that piecewise function. You can watch that one a couple times. So all of those are piecewise functions. Just an introduction. Hope it helps. Remember to like and share and subscribe to my channel if you haven't already. and we will see you guys later. Bye.